All right, so I felt like I'd go through a bunch of the problems. I just had a wild hair that I wanted to do something on a Sunday, apparently. This is for y'all, so I'm going to go through the student version of all this and kind of talk about several of these problems. I don't want to make the video too long, so if I skip stuff, that's the reason. And if I stop talking right now and just get into it, that's also the reason. So let's look at a few of these. So we've got these, and it's like, what facts about angles did you use? So first, we need to kind of look at them and kind of go through it. So some things you guys might not remember, or you might have been distracted in class, and so this is the purpose of this. Vertical angles. So let me point something out. Let me kind of color code these things. Vertical angles, when you have it, when you have something like this, you have a bunch of angles that, a bunch of angles formed by lines that are intersecting each other. You have something called vertical angles. So a vertical angle would look a little something like that. Those are vertical angles. And whatever, if we said, hey, here's an angle and here's an angle, you guys can kind of visually look at it and see what it looks like. So those red ones, or those fuchsia ones, are vertical angles, and those cyan ones are vertical angles. So really, we only need to know one of these angles to actually know what it is. And they gave us that this one's 36. So vertical angles are congruent. They're the same. So vertical angles are congruent. And we're going to use that a lot in here. And there's a lot of different ways to prove each one of these, but since vertical angles are congruent, we know that this one right here is also 36 degrees. Now, it says determine the measure of the missing angle, and this one's labeled as x. But what's cool about this is we don't have to stop here. We can find all of the rest of them with our properties. So that one's 36 because those are vertical angles. They're always the same thing when they form like that. So like this line right here, and this line right here are forming a bunch of angles. So this one's a vertical angle because this line and this line right there are forming that, and that is why it's the same as that. Kind of messing up my colors here there. So sometimes using, in a later one, I'm going to use it to where we have multiple angles that show up to help you not get them confused. But since we know this one's 36, we have this idea of supplementary angles. Supplementary angles. And really, it's because we know to go all with it, when we have a line that's formed like this full angle to get from one side of the line to the other. Let's just say we're starting right here, and we're rotating around this thing to get to right here. So the angle that we have to subtend or go through, form, a lot of different words we can use, is 180 degrees. But this can be split amongst a bunch of different angles. So when you have angles that are consecutive angles, these two are consecutive angles. That's the word that we're going to use here. So supplementary angles is basically saying consecutive. I'm realizing I don't remember how to spell consecutive. That doesn't happen to me a lot. It's a C right there, I'm pretty sure. Consecutive angles. Whatever, y'all can look up the spelling. This is the first time that I've had an issue with this word, but I'm tired. It's a Sunday, and I'm doing this for y'all. So consecutive angles around a line are 180 degrees. So the angle measurements equal 180 degrees when you add them together. So let's take this, if we want to figure out what this is, let's call this A, just for funsies. And let's say that that x plus A, because those are the only two angles that are forming, that are going from one side of the line to the other, have to equal 180 degrees. X, we know, is 36. And then subtracting 36 from both sides, doing a little bit of that algebra to get A equals 180 minus 36. So 180 minus 36, we got a 4 right there. That drops down to a 7, a 4, 144 degrees. And what's cool about this, since we know that these two are vertical angles right here, we know that this one's got to be 144 degrees as well. And now when we go through each one of these things, we can actually prove it to ourselves. So going from here to here, it's got to add up to be 180 because those are supplementary angles. So 36 plus 144, also 180. So you can just keep going around the circle and prove and confirm all of these if you want. Same thing here. This one right here, this is a line, and then you've got two angles right there. So to go from this whole angle right here, doesn't really matter where I draw that, but that whole angle about this point right here, they're supplementary. They're gonna add up to be 180 degrees. So really we just gotta do 121 degrees plus whatever y is equal to 180, and we can do a little bit of algebra again to get y equals 181 minus 121. You've got a 9 right there. 7 minus 2 is 5. So it's going to be 59 degrees. 59 degrees. So that means that y has got to be 59 degrees. Pretty quick and easy. Now, what's cool about this, and it still applies to that whole supplementary angle thing, that's not a separate property. That all comes from the fact that if we were to have a bunch of different rays or line segments or lines coming from a given point, if you start, like let's just say we start right here and we go all the way around. Well, we went all the way around a circle, which means that all of those angles, however many are there, have to add up to be 360 degrees because we basically just went down around a circle. So 360 degrees will be all of these angles added together. This is called, there's a lot of words for this, but it's the sum of angles around a point. Around a point equal 360 degrees. So when you add up all the angles around a single point, it's going to equal 360 degrees. So let's go ahead and do that. Let's say that z plus 82 plus 172, whatever these are, those are the only angles, those are all the angles added up together around a single point, have to equal 360 degrees. So let's just go ahead and simplify a little bit before we do any real operations. So 82 plus 172, we're going to get a 4. We're going to get 8 plus 7 is 15. Carry the 1 to get 254. I put an equal sign. Ignore that equal sign. Z plus 254 is equal to 360. We're going to go ahead and subtract 254 from both sides. Do a little bit of that algebra to get Z is equal to 360 minus 254, which is like 106. Let me confirm this. 10 minus 4 is 6. Yeah. 6 gets reduced to a 5. Minus 5 is 0. Excellent. 3 minus 2 is 1. 106 degrees. And you can confirm this as well by adding up all of them and seeing if it's equal to 360 degrees, because we're forming a circle when we go all the way around it. So we're really just saying the sum of angles around a point is 360 degrees. So when we fill this out, the first one is vertical angles are congruent. And that's all we really need because we only cared about x. On this one right here, we have supplementary angles or consecutive angles. The sum of consecutive angles about a line equal 180 degrees. And what's interesting about this one that's going to carry over to the rest of the problems is that we still can use sum of angles around a point on this one. Let's just assume that point is there. To go all the way around the circle, it's got to be 360 degrees. Well, we know right here, using that consecutive angles, at a line right here, we've only got one, but it still works. These consecutive angles because are supplementary, and there's only one of them here, so that has to equal 180 degrees. So you could do that, and you could say 121 plus y plus 180 degrees, because this is 180 degrees right here, equal 360. It's just you're just going to always have the same thing as you would normally have with supplementary angles. We don't have the ability to discuss right now, so I'll talk about that in a separate video. But let's talk about this one. So it says, in the figure, what is line segment AD is drawn. Let me show you what that means, just so you know. We name our line segments by the points at the end of them. So AD is this line right here. That one I just drew in teal, or cyan, rather. In the figure, line segment AD is drawn. Find the measure of DCE. So that's what this means. That M right here means the measure of the angle DCE. So just to underline each part, the measure of the angle DCE. That's what that means. Don't let that get super confusing. It's all there. And but when we're talking about that, there's a lot of stuff we can learn from angles. So we use that notation to say it's the measure of the angle DCE. So whenever we measure, whenever we label our angles, we do it by the points. So this right here is D, C, E. Do y'all see how when I do that, if I were to connect these dots like this, this is the angle between those. We have to have 3 points to designate our naming convention for an angle. So DCE forms an angle. So when we're looking at this, we're trying to find the measure of this angle. So the measure of this angle, DCE, is that. Now, if you want to, like if it won't confuse you, you can always just say, I'm going to call that little a, or little e, or whatever letter you want. It doesn't really matter. You can just put a blank right here if you want to find the measurement. You could say equals a blank. Now, the LEAP is going to ask you for that specific notation. It's just going to say, it's going to give you that. So you want to get good at the notation and at a lot of the vocabulary, because it's not going to ask you the vocabulary. It's going to use it, and you're going to have to know what it means. So you got to make sure that we're clear on that, and make sure that you ask questions about it if you don't understand it. But if I want to find the measure of this angle, I have to use a lot more information than this. So I'm going to put it in this right here, in this color, and I'm going to use the fact that consecutive angles at a line like this. You see that? You see all those angles that make that line? So we have a line. To go from one side of the line to the other, we have to go through an angle of all of those little angles. So all of those added together need to be 180 degrees. So we know this one right here is 72 degrees. I know it's kind of hard to see, but that's a little degree symbol, and that says 72. So 72 degrees plus whatever this is. But looking at it, we can see that it has this notation, which means that it is a right angle, which means that it is 90 degrees. And now you can use whatever you want for this. You can write this whole thing out if you want, or you can just use that's why I was suggesting, maybe you just call it a letter or something, you know what I mean? Maybe just call it some letter. Or you could just use that notation. This entire thing could just be called A if you want to use it, if it makes it easier. You could just put a blank right there, you know, like I was talking about using a blank. But no matter what, when you add up all those angles, it has to be 180 degrees because they're supplementary. So let's go ahead and simplify this a little bit. We have all the information we need. 72 degrees plus 90 degrees is 100 and, 62 degrees? Zeros of 2, 7 plus that, yep. Plus blank equals 180. Subtract 162 from both sides. Technically, we would consider this a unit, so I can keep drawing it, but I don't really need to. If I'm only messing with angle measurements, then technically the units would completely cancel. So I don't really need to draw my degree symbols right here over and over again. So we really have blank equals 180 degrees minus 162, which is an 8 right there and a 1, and then, okay, so 18 degrees. That's what that would be. And all of these are going to use the same thing. So the words that I would use would be that my consecutive angles are supplementary. So they must sum or add to be 180 degrees. And then I'd say, considering ECB or BCE, whatever you want to call it, BCE is 90 degrees, and ACB is 72 degrees. Since all of these, DCE, ECB, and BCA, are consecutive angles and supplementary, you add them together. Their sum must be 180 degrees. So that's just an idea of just using my words to say, to kind of tell somebody else that might not know or might not be looking at the image, or the image might not be accurate. It lets them know the information given and how to get the unknown information. So let's look at this. This is the same thing. We have a point where all these lines intersect or meet. Well, these are line segments, so they all share a common point that we're calling K. And so to find the measure of angle IKH, the order doesn't really matter here. We're not dealing with vectors or anything like that. So the measure of angle IKH is a mystery. But we know that the sum of angles around point K equals 360 degrees. So we can go ahead and say, all right, well, all of our angles around that point, K, 133 degrees. I'm not going to write my degree symbol right now. Plus 147 degrees plus blank equals this right here. So kind of simplify, but it has to be equal to 360 degrees. So that blank is this. Is what I meant to say. So let's add them together. We have 7 plus 3 is 0. Carry the 1. 4 plus 3 is 7, 8. And then we have a 2 right there. Keep writing my, being inconsistent with my degree symbols. So let's look at this. Let's double check our work. We don't want to make mistakes at this point. So then we can subtract 280 from both sides. So blank, whatever that is, I could just write this if I want. You don't have to write a blank. You can actually write a variable and just call this like A or something, or you can leave it as a blank. It doesn't really matter. A lot of this we're going to be able to do in our head, but we need to actually call it something when we're describing what we're doing to somebody else, or if we're proving it. Okay, so subtracting 280 from both sides, I get whatever this angle measurement is, this blank, this measure of angle IKH, or whatever they called it. 260 minus 280 is going to be, that's a 4 right there, 40 degrees, I feel. What am I talking about? 80 degrees. You just skip past what I just did a second ago and pretend it didn't happen. So it's going to be 80 degrees right here. So whatever this is 80 degrees, because the sum of angles around a point is 360 degrees. Since the angle HKG, the measure of angle HKG is 133, and the measure of the angle GKI is 147 degrees. If all of these angles sum to be 360 degrees, then K must be 80 degrees. Now this one I'm not going to belabor too hard. We can use a lot of different things. Vertical angles have blank measure, equal measure. Two angles are vertical if their sides form opposite rays. So in this case, the answer to this would be equal measure. Vertical angles have equal measure. And just as a reminder, this and this are vertical angles. And this are vertical angles. I know it's a little confusing with the idea of vertical because like these look like they could be called horizontal angles, but again, I don't believe we have a term of horizontal angles in that case. I feel like if we call them horizontal, you know, that's more aligned with adjacent angles, which is like this. These are adjacent angles, but these are vertical angles. So let's look at this. Let's say, so if these are vertical angles, these ones in fuchsia, then these have to be the same, 52 degrees. And what we're trying to find TRV, that angle right there, I've already got it. But if I did want to find the rest of them, I'd just say that if these angles right here have to sum up to be 180 degrees. So I'd really just say, all right, well, 180 minus 52 equals this right here. And I'd get that by saying this angle right here plus 52 is equal to 180, and then I do the algebra, or I just subtract them straight out. It doesn't really matter. You can go back in the video to see how I did it before with the other notation. But either way, that we'd figure out what our thing is, what this angle right here is, just by doing that. And it looks like it's 8, 2, 1. 128 degrees, it should be. If I make a mistake, correct me in class. And then since I know that this is 128 degrees, that means using the vertical angle property that these two are both the same. Now you could also, again, if maybe you don't think about that. Maybe you don't want to look at it as just a line. Maybe you want to look at it as all of them. Using the vertical angles right here, 52, we know that all the way around the circle, you just have to add up all your angles. So 2 times this plus 2 times this will equal 360 degrees because these are vertical angles, so these are going to be the same. A lot of ways to do it. Same thing right here. These are supplementary. So these two adjacent angles are going to add together to be 145 plus A is equal to 180. So really just subtract 145 from 180 to get A. With enough practice, you'll be able to just look at these and do it. In a problem like this and this are vertical angles. So that means that C is equal to 40. Got that information straight off the bat. Using this line and kind of looking at the angles that are the consecutive angles are next to this line, they have to add together to be 180. So 40 plus B equals 180. Subtract 40 to get B is equal to 140. It is a vertical angle with D, so that means that must also be 140 degrees. See how one angle can just give you all the information you need? Now, if there was a line here, we could do something a lot easier, but like we're just going to have to use the sum of all the angles around a point. So we could just call this the point where they meet, or they intersect, or they shared vertex, whatever you want to call it in this case. That point right there, all of the angles around that point have to sum to be 360 degrees. So E plus 117 plus 146 equals 360. I like simplifying first to get 7 plus 6 equals 13. So 6 right there, and then that's 2. There's a lot of ways to do that math. You can just throw in a calculator if you want. There's so many ways to do it. If you need tips or a review in just adding quickly, like mental math, please ask. Because the less we have to use a calculator, the less likely we are to accidentally push buttons wrong. But again, you could easily make mistakes on this too. So it's up to you with what you're most comfortable with. So let's subtract 263 from both sides. And then let's do 360 degrees minus 260 degrees. There's going to be a solid 7 right there. 9 right there. So 97 degrees. So that should be 97. And we can go try to add them up again to make sure that we didn't make a mistake. They should all add up to be 360 degrees. If I make a little tiny goof, call me out in class. So if you fill out this table right here, you can get all of that. So A is this one right here. So the measure of A, we said, oh, I know I erased it, but that's okay. It's like 35. Because 145 plus A equals 180. So in this case, consecutive angles were supplementary. Oh my goodness, I'm just never gonna write. I'm never gonna write this again. So let's see. Consecutive angles are supplementary. You can also just say that the sum of these angles about a line, supplementary. But you know what I'm gonna do just so I can stop goofing because my brain is not in the right spot today. Consecutive. I was spelling it right earlier. I looked it up just to make sure. Consecutive angles adjacent to a line, a lot of that stuff, but I'm just going to do like that. Supplementary. And I actually believe it's somewhere up here. The sum of angles on a straight line is 180 degrees. Now that could be some good wording for this too, so you don't have to try to spell consecutive and embarrass yourself over and over again like me. I'm going to add that to the list of the words that I can never remember how to spell right. And there's only one other word, and that's guardian. I don't know why guardian. I get the U and the A messed up. Yeah, but like in class, in Q&A section, why don't you guys put down like what words you guys have difficulty spelling? Because everybody's going to always have something. There's always going to be something. So the sum of angles at a straight line, 180 degrees. And I'm not going to go through each one of these because I explained them in context, but like right here, if I want to find B, I could say that I could do it a lot of different ways. I can go a lot of different directions. I could have said that the sum of these angles are about a straight line are 180 degrees or are supplementary, so they're whatever. They sum to be 180 degrees, and I can say that it's got to be 140. And then I can say that I can go down to D, and I can say that it's also 140 because it is B and D are vertical angles. And then I can say it's 40 because because it's also vertical angles, but they never labeled this, and they don't have any points labeled right here, so calling out this is kind of difficult. But you can always say that, for this angle right here, it was given, and C is a vertical angle with that angle. You can call it something. It doesn't really matter. There's a lot of ways that you can word this, so don't stress out too much about it. And then with E, it's 97 because sum of angles around a point. Equal 360. Sum of angles at a straight line maybe we just fill out all of this just to make sure we have it. So for B, I'm just going to put ditto marks right here. And then for C, I can say vertical angle with given angle. Just so that if we want to look at it, we really know. So I'm not going to belabor most of this. This is the same thing. Sum of angles at a straight line is 180 degrees. 144 plus A equals 180 degrees, and then just do the algebra. Same thing here. Once you master these skills, you realize that a lot of it's going to keep repeating itself in this lesson. 97 plus 36 plus B equals 180. Work the algebra. And that's, again, the sum of the angles at a straight line is equal to 180 degrees because they are supplementary. This one looks harder, but it's not. The sum of angles at a straight line is 180 degrees. Wild, I know. It's like spoilers. I keep saying the same thing. But you might think that you don't have enough information. So it's going to be 40 for this angle plus 36 for this angle plus C for this angle plus... What's this? Uh-oh, it doesn't have an angle measure marked. Ooh. Oh, wait. I know what that symbol means. It means it's 90 degrees, so you do have it. So I'd simplify the left side to get 40 plus 36 is 76 plus 90 is 166. And then I'd subtract 166 from both sides to get C is equal to whatever that is. So it's like 14, I believe. 10 minus 6 is 4. Reduce that. That looks good. C is 14 degrees. Or the measure of C, the measure of angle C is 14. Same thing here, but you might think to yourself this, like you don't have enough information, but notice these two, it's telling you they're both D, so they must be the same. So you can write this as 82 degrees plus D equals 180. Or you can simplify first and realize it's just going to be plus 2D equals 180. And then subtract 82, do the algebra to get 2D equals 98. And then divide both sides by 2 to get 49. We're just using our algebra. If you need an algebra review, double check Khan Academy, and you might be able. We might make an algebra review playlist just in case you guys can practice that. This is the exact same thing. It looks hard, but it's not. You could write it all out and say 91 degrees plus 91 degrees plus 91 degrees plus G plus G plus G equals 360 degrees. But we're just using the idea that all of the angles around a point are equal to 360 degrees. So really you can say 3G, because you have 3 G's here, 1, 2, 3, plus 3 times 91. You could write it as 3 times 91 if you want. Or you can write it as 91 plus 91 plus 91, because that's the definition of 3 times 91. Or you can write it as, you can just do the math and like do the arithmetic and figure it out yourself. 91 plus 91 plus 91 should be equal to 273. Or you can say 91 times 3 is equal to 273. It doesn't really matter. But regardless, all of those angles added together should be equal to 360 degrees. So we'll just do the algebra. We'll subtract 273 from both sides. And then whenever we get with that, we'll divide both sides by 3 to get it off of the G, and we'll get exactly what G is. And I'll let you guys work that out so you can get some practice. This is going to be the exact same thing. Just add them all together. 85 plus 35 plus 2x plus x equals 360. 85 plus 35 is 120. 2x plus 1x. If it's not written, it's implied to be a 1 right here. 2x plus 1x is 3x. Subtract 120 from both sides to get 3x equals 240. And then divide both sides by 3 to get x equals 80. Now, this one's kind of a rough one. Okay? All right? It's not super rough, but if you mess up, if you goof it up a little bit here, you're going to get 2 variables with 1 equation. I'm going to save this for another video because I know you probably need a brain break.